Okay, LT1 for this unit is distinguish between irrational and rational numbers. So we're going to look at numbers and decide if they're rational or irrational. It's just a way to categorize numbers. And we're going to be looking at both of these types of numbers in this unit. So a rational number, the first thing I want you to write down is that it comes from the word ratio. Okay, so any rational number can be written as a ratio. And when we think about ratios in math, we often think of fractions. So the definition is any number that can be written as a fraction. So it might be a common fraction like we're used to seeing, like 1/3. It could be an improper fraction like 4/3. It could be a fraction like 10/1. Any of these could be negative, just any number that can be written as a fraction. And like I said, the word comes from ratio. Now with irrational numbers, it is a number that cannot, so you might want to underline that, be written as a fraction. So it's just the opposite. If you have a number and you can't write it as a fraction, it's an irrational number. The decimal for this number is going to go on forever without repeating. And there's not going to be any pattern. So let's look at these types of numbers in a little bit more detail. We have rational numbers and irrational numbers. Now, all of these types of rational numbers, so any of the numbers that fall under this umbrella from here to here, have a distinct pattern. Okay, there's a pattern that goes on with these numbers. And then for irrational numbers, there is no pattern. So go ahead and jot that down. So let's look at the different types of rational numbers. So first of all, you can have whole numbers. So you can have any whole number that you want. You could have the whole number 5, and then another irrational number, or excuse me, rational. These are rational numbers. Another rational number would be its negative. So 5 and -5. You could have the whole number of 2, and then again, any negative would work as well, as long as it's a whole number. Okay, it can be the number 973, okay, or -973, but any whole number is a rational number. The reason, if we think about this, we can write any whole number as a fraction. Do you know how? You can just put it over 1, okay, so that's why it's a rational number. There's this ratio, or this fraction we can write. Now, another type of rational number is a fraction that's made up of whole numbers, and this fits in directly with the definition of a number that can be written as a fraction. So we could have a fraction of 6/25. We could have a fraction of 1/4. We could have a fraction of 1/3. We could have an improper fraction, that's fine, of 5/4. We could have 3/11. We could have 11/11, which would just be 1. Like I said, we can have improper fractions, that's fine. And then any of these could be negative as well. Okay, so those are rational numbers because obviously they can be written as a fraction. Okay, then we have perfect squares. All right, you've probably heard of these before. And these are numbers that when you take the square root of that number, you get a whole number answer. So we're going to write some common perfect squares. So we can have the square root of 1. All right, that's a perfect square because the square root of 1 is 1. 1 squared is equal to the square root of 1. Or excuse me, is equal to 1. So the square root of 1 is equal to 1. It also equals -1. We'll talk about that later in the unit, but for right now, let's just write down the positive. Okay, the next one is the square root of 4. That's equal to 2. 2 squared is equal to 4. The next one would be the square root of 9, and that's equal to 3. Then we have the square root of 16. That's equal to 4. Then the next one after that is the square root of 25. That's equal to 5. Then we have the square root of 36, which is equal to 6. We have the square root of 49, which is equal to 7. The square root of 64 is equal to 8. The square root of the next one would be 81, which is equal to 9. And then we have the square root of 100, which is equal to 10. And we could keep going because this side would be, the next one would be 11, and then we'd have the square root of 121. Okay, 12 is the square root of 144, and so on. Okay, so these never end. They keep going because we just keep increasing these numbers by 1. All right, now these numbers are going to be rational numbers because when you take the square root, like if we take the square root of 100 and we get 10, we know that we can write 10 as 10/1, which is a fraction, so these are rational numbers. okay? Just kind of an aside, one thing, when you're trying to find the perfect squares, there's a pattern to this, okay? So if we go from 1 to 4, that's going up by 3, and then 4 to 9 is going up by 5, and then 9 to 16 is going up by 7, and then the next one's going up by 9. So they keep increasing by odd numbers, so 3, 5, 7, 9. The next one goes up by 11, and so on. That's not anything you really have to know. It's just kind of a nice pattern with perfect squares. All right, the next type of rational number we have would be terminating decimals. If something terminates, it means that it stops or it ends. So some terminating decimals, it just means that they don't go on forever. So one terminating decimal would be 0.25. We know that this is 25 over 100, which is, of course, 1/4. So there it is as a fraction. Okay? Any decimal that stops can be written as a fraction. So 0.125 can be written as 125 over 1,000th. It's 125 thousandths, so we could write that as a fraction. Okay, here's another one, 0.0625. We could write that, okay, over as a fraction. 0.75, 75 hundredths, 6 tenths, 1 and 2 tenths, so 1.2. So you can have this whole number out in front, okay. You can have something kind of crazy like 3.5267. Okay, the decimal can be long, but as long as it stops, it terminates, so it's a rational number. You could write that out as a fraction. All right? Okay, so the next one would be repeating decimals. These have a pattern to them. That's the key on repeating decimals. So if we have 0.3 that keeps going, 0.33333 that never stops, one way to write that is with a little bar over the top. You've seen that before, or maybe a dot, dot, dot to show that it continues. We know that this decimal is what happens when you have 1/3, and you divide those, you end up with this repeating decimal. Okay? Now, repeating decimals, there might be 2 digits that repeat, so 0.12 repeating. That just means it goes 0.12, 12, 12, on forever. There's that pattern. Sometimes some of the digits don't repeat, like 0, 8, and then if the 6 is repeating, that's still a pattern, so that one's fine. You can have a whole number out in front, okay, like 2.6 repeating. That'd be 2 and 2/3, which you could write as an improper fraction, or 3.7 repeating. Those are all options, okay. If there's a pattern, then it's fine. All of those are rational numbers because when it comes down to it, you can write them as fractions. All right, let's go on to irrational numbers. Irrational numbers would be things like non-perfect squares. Here's what we mean by that. If you take the square root of 7, that doesn't come out to be a nice even number. Okay, I'm going to show that on my calculator. If I take 7 and then the square root of that, it's 2.6457. There's no pattern to this. It's not a whole number. So that's going to go on forever. So it's like 2.6458, and then you'd have to round it eventually. So there's no way to write that as a fraction because you'd have to round it. The square root of 27, same thing. The square root of 39, same thing. Square root of 50, same thing. Any square root that doesn't fall in line with these over here, these perfect squares, is going to be a non-perfect square. It's going to be a decimal that never ends, and you can't write that as a fraction, so it's an irrational number. All right? And then we have non-terminating, non-repeating decimals. So these are decimals that don't stop and don't repeat. Okay, so it might be something like, you might see something like written 2.7561 dot, 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 okay? That just means that it keeps going, and there's no pattern, there's nothing repeating. Can't write it as a fraction, irrational number. Another one that you've seen before is pi, okay? Now, pi is, you've seen that, and it has to do with like finding the circumference and area of circles. And oftentimes we abbreviate that or round that to 3.14, but it turns out that those digits keep going. In fact, they go on forever, okay? So it's really like 3.14159, and then it never stops, all right? So that's an irrational number. There's a number called E that you'll talk about someday in advanced algebra, and that has to do with probability and compound interest when you're earning money. Okay, and that number is irrational. It's 2.71828, and then it just keeps going forever, never stops. So there's no way to write that as a fraction. So there we have it. Rational numbers are in this category. These categories over here, they have a pattern, and irrational numbers do not have a pattern. Okay. Now we're going to look at classifying some different numbers, and we're going to choose whether it's rational or irrational and explain why. So we're going to abbreviate this. Let's use an R for rational and a capital I for irrational. So looking at 5, I'm noticing it's a whole number. I know that that means it's a rational number. For my explanation, I'm just going to show some work here. 5 is equal to 5 over 1. There it is as a fraction. Well, and then really this fraction is the same as we could multiply them both by 2 and get 10 over 2. We could do that again and multiply each of these by 3 and get 15 over 3. But moral of the story is it can be written as a fraction, so it's rational. Okay, negative 25 hundredths, that's going to be a rational number because I can write it as negative 1/4. Okay, I knew, like, if you don't know that that's negative 1/4, you can use the decimal system to know that that's negative 25 over 100, which is equal to negative 1/4. But regardless, it's a fraction, rational number. Okay, square root of 19 is irrational. Here's how I know that. The square root of 19 falls between the square root of 16, which is 4, and the square root of 25, which is 5. Okay, so it has to be between 4 and 5. It's going to be this decimal. It's like 4.3 and then a bunch of numbers. Square root of 19 is not a perfect square. Irrational. Pi is irrational. Okay, it's 3.14159, etc. Okay, so let's go ahead and write that it never ends and there's no repeats. That's really the best definition we would have of an irrational number. Okay, we could write it for the square root of 19 as well. Okay, 0.18 repeating. It's a repeating decimal, so that's a rational number, and I'm going to write that repeating decimal for my explanation. Okay, that falls into that category of a rational number. And actually, when you have these digits repeating, it turns out that 0.18 repeating is actually 18 over 99. You don't need to know that, but it is. All right, 7.5. This is a terminating decimal. The decimal stops, so it's a rational number. Okay, you could write that it's a terminating decimal. What I'm going to do is I'm going to say that 7.5 is the same as 7.5, which is equal to, multiply this by 7 by 2 is 14 and add 1, so that's 15 over 2. So there it is as a fraction. Okay, 18 over 47. 18/47 is rational because it's a fraction. Okay, 0.3 repeating is rational. It's a repeating decimal. And you probably know the fraction for this one. It's a pretty common one. We've talked about it. It is 1/3. Okay, so you could write that as well. This one, 6.3871, the dots mean that it keeps going. Okay, so it's irrational. It never ends. And there's no pattern. Or no repeats. Okay? And then the square root of 81, that's a perfect square, so that's going to equal 9. Okay, it turns out that it also equals negative 9. We're not really going to worry about that part right now. And this is rational because 9 is the same as 9 over 1. So there it is as a fraction. So we have a rational number for this one. All right, so you have some information now on rational and irrational numbers. Rational numbers can be written as ratios or fractions. Irrational numbers cannot. So go ahead and write your own rational number, or just write a couple of them, and then irrational as well.